4.1, solving system of linear equations by graphing. Objective 1, decide whether an ordered pairs a solution of a linear system. We know that an equation of the form of ax plus by is equal to c is a line when graphed. Two such equations are called a system of linear equations, like you can see right there. Right there, okay? Just in case you didn't see that, there. A solution of to a system of linear equations is an ordered pair that satisfies both equations of the system. For example, 3x plus 2y equals 8, 4x minus 3y equals 5, and this is saying that 2, 1 satisfies the system, meaning it's a solution for both. Since two lines may intersect exactly at one point, so I'm going to highlight that with a purple. The other one may not intersect at all and may intersect at every point. It follows that the system of linear equations will have exactly one solution, will have many solutions, or will have infinite solutions. And those are the only three that you can have. No more, no less. Either you have one answer, infinite many answers, or no answers at all. So let's see what this means. So if we have this, and two lines are intersecting at one point, something like this, then this is what this is telling us for the purple. Now, if we have like so, and they're not intersecting, that means that the lines are parallel to each other. So since they're parallel to each other, they will never touch each other, thus no solution. Finally, we have this. And we have another line. Let's just make that and assume that this is crossing right on top of it, perfectly aligned. Okay? And this is it. So this means we have on this one, on the yellow one, we have infinite many solutions. So this is one solution, no solutions, and infinite many solutions. Okay? So let's say we have 3, 2 as a solution of the system, and we have to determine if that is true. Well, we already did this type of a problem. We only did it with one line. Now we have two. Before, the only thing we used to do is substitutes, and we're going to do the same thing again. So this is an x, this is a y. So I have negative 3 times 3 plus 6 times 2 is equal to 10. That's going to give me negative 9 plus 12 is equal to 10. Okay? So negative 9 plus 12 will give me how much? What? So that's going to give me 3 is equal to 10, which this is false. Since this is false, this is not true. Then 3, 2 is not a solution. Okay? So we don't need to continue, but let's do it anyway. So I have 5 times 3 minus 8 times 2 is equal to negative 2. That's going to give me 15 minus 16 is equal to negative 2. Negative 1 equals negative 2. Again, this is false. Okay? So objective 2, solve a system of linear equations by graphing. We already know how to do this. We could either use 4x. We have two ways up to now to graph. It's using standard form and create our little table, giving random numbers, or the other option to graph is use slope intercept, which is y equals mx plus b. Okay? On this one, I will stick with the points. So we're going to be using standard form on this problem. So we have 4x plus y is equal to 4. I'm going to give x and y. I'm going to give the value of x 0. So I have 4 times 0 plus y is equal to 4. So y is equal to 4. Now, I'm going to give the value of 0 to y. So I have 4x plus 0 is equal to 4. I have 4x is equal to 4. So divide by 4 both sides. So I have that x is equal to 1. Okay. Next, I have my 2 points for that one. Now I'm going to do 3x minus y is equal to 3. X, y, I'm going to let x equal 0. So I have 3 times 0 minus y is equal to 3. So therefore, I have 0 minus y is equal to 3. So negative y is equal to 3. Divide by negative 1 on both sides. So y is equal to 3. Now I'm going to let y equal to 0. So I have 3x minus y is equal to 3. This cancels. So I have 3x is equal to 3. Divide by 3 on both sides. So x is equal to 1. So if you notice something, we can see that our point is crossing at 1, 0. They both have 1, 0. So therefore, our solution, let's change that to another color so we don't get confused. So our solution is 1, 0. We already know that just by seeing this, but not all the time is going to work like that. So let's continue working this, what we should be doing. So I'm going to make another page because I ran out of space on this one. I'm going to put a dotted line so we can do fairly like that. And I'm going to return to copy our 2 tables. So I have copy that. And I'm going to use the other one as well. Copy the other table. Copy that. Paste. Okay. So now that I have my 2 tables, let's make our coordinate point, my coordinate graph. That's going to give me 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So there we go. Our first point on the red line. So let's go back to my red. It's 0, 4. So I have 0, 1, 2, 3, 4 right there. And the other one was 1, 0. So right there. So that's our line. Then I have, for the purple, I have 0, 3. So 0, 3 right there. And 1, 0 right there. Sorry for that. And that it looks like that. Sorry. And as you can see, as we had predicted, it is crossing at 1, 0. But this demonstrates a flaw with this system, or this method. So note, unless you have graphing software, do not use this method. And you're going to ask why. Well, you can see my lines that are not that perfectly straight, are they? So that's a flaw. We can't predict. Look how close and horrible my lines are. And unless I have a ruler, and even with a ruler, I'm not sure I can do this anything that much better. So that's why we also have algebraic method of solving this. But we'll get to that when we get there. For now, we're just going to continue practicing with this. But again, this is a method that I do not like that much. So in order for this method to be useful, you must graph the lines very accurately. And that's the message right there, accurately. We can't draw. Our hands are not that accurate. So let's continue doing this anyways, okay? So we have, again, the same way. I'm going to allow 2x plus y is, well, let's change the color again. So 2x plus y is equal to 6. Now this time I'm going to be using y equals mx plus b to solve this, okay? So I have minus 2x to both sides. So I have that y is equal to negative 2x plus 6, and that's all I need. The other one says minus y is equal to negative 2 minus 2x to both sides. So I have negative y is equal to negative 2x minus 2 divided by negative y, both sides. So this becomes y equals 2x plus 2. And again, that's all I need to graph. Let's create our coordinate plane. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the red one states to go up 6. 1, 2, 3, 4, 5, 6. And then to go down 2, 1, 2, and 1 to the side. That's it. Now the green's telling me to go up 2, 1, 2, right there. Then go up 2 more, 1, 2, and 1 to the side. And this looks at our solution is at 1, 2, 4. Because that's where they're intersecting, okay? Again, this was hard. This is not how it's going to work most of the time because graphing, we're not good at drawing straight. Use graphing to identify systems with no solution or infinitely many solutions. Okay? And we already went through this. This is one solution, which we were doing before. This is no solutions because the lines were parallel. And finally, it's one line over the other. That's infinite many solutions. So look at this one. This one's already how we wanted to graph. So let's just do that. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is telling me, I'm going to surround this. This is a right one. And it's telling me to go down 3. 1, 2, 3. So that's my first point. Then it's telling me to go up 2 and 1 to the side. So 1, 2, and 1 to the side because of the slope. So we have this line. Now let's do the next one. 2x plus 7. This one's telling me to do 1, 2, 3, 4, 5, 6, 7. Then go 1, 2, and 1 to the side. And again, this answer is no solution. I know this because we will find out. But according to my drawings or my graph, they will meet eventually. If we continue this trend going like this, and this one going like this, they will eventually crisscross. But the reality of this one is no solution. So again, note the flaw of answering a system by graphing is the human factor. So it's a way I don't support that much, but I still need to teach. So let's do this one. And again, it's already in that form. So let's start the graph. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3, 4, 5, 6, 7, 8, 9, 10. Okay? I think I went a little bit overboard with that. There we go. So, the first one, the red, I'm going to leave it in red color. It's telling me to go down 2. So 1, 2, that's my intersection. Then slope's telling me to go up 3. So 1, 2, 3, and 1 to the side. So it has to look something like this. Let's do the next one as a green, sorry. It's telling me to go up 1. And then for the y-intercept, and it's telling me to go up 3. 1, 2, 3, and 1 to the side. And again, these are parallel to each other, so we have no solution. Now, let's go back to the previous example. What do they have in common? Can you see anything that the both equations have in common? They both have 2 as a slope, and on this one, both have 3 as a slope. So they have the same slope. Therefore, note, when 2 equations have the same slope, you will always get no solutions or infinite many solutions. Okay? And that completes today's lecture.